Okay, so this week we have a test, and we're going to be doing one of the lessons is going to be a review, just in case you're confused on how to use any of the gas laws. So what we're going to be doing is going over all of the gas laws you're required to use, and then you're going to take your test Friday. So let me write that in here. Your test is Friday. And then that would be, I think, April 17th. Yep. So Friday, 17 April. This is for everyone. And then you have from 6 p.m. to 7:30 p.m. to take the test. So this was not my call. But this is the allotted time that we have to take the test, and you have to do it in this time frame. If not, I don't know what's going to happen. I think you just get a 0. But this is our allotted time frame, and that's when you're going to take the test. Okay, anyways. So let's go over some problems. And we're going to go over gas law. I'm going to just make these up as I go, because, really, you can't... You can only look so much of these up online, but we're going to go over everything again. So, anyways, we'll do a Boyle's Law problem. And what I'm going to do is key you in on what you should be looking for when you're looking at this. So, Boyle's Law is when you have a constant temperature and the pressure and volume are fluctuating. So keywords that you're going to need to look for. So you have, I dropped my pen. Keyword in the problem. And this is for any problem, even if it's homework. So your keyword is going to be constant temperature. So you have a constant temperature and you have pressure and volume. So how this equation would be is P1 over V1, times V1 equals P2 times V2. These aren't very difficult to solve. They're actually super simple. But we're going to do it anyways. So say we have a gas at constant temperature occupies a volume of, we'll say, like 3.21 liters at a pressure of, we'll say, 5 atmospheres. And then if the pressure increases to, 10 atmospheres. Let's do a little harder. 7.32 atmospheres. What is the volume? So that's kind of what the problem is going to look like. Again, not complicated, but you have to be able to know what you're looking at. So keyword is right there, constant temperature, or keywords. And then we have our volume 1 and pressure 1, along with our pressure 2. So let's plug it in. We have 5 atmospheres. times 3.21 liters equals 7.32 atmospheres. And then that's times volume 2. So we don't know what that is. So that's horrible. So you divide out the atmospheres on both sides, and then we use a calculator. I closed it, so let me open it again. So, and then just so you know, atmospheres cancels and you're left with liters. 5 times 3.21 divided by 7.32. So now we have V2. V2 is going to be equal to 2.19. And that would be your answer. That's how you solve any Boyle's law problems. Okay, so now we're going to move on to Charles's law. Let me see what I'm doing on time. Okay, I'm good. So Charles's law, so you have the volume of a given ideal gas at constant pressure. So your key word, constant pressure. Let me change the color of that. I know it's not the same as the other one, but I can always fix that. Here, I'll fix that. Okay. Wow, that's super annoying. Okay, so keyword for Charles's law is constant pressure. So if I said, that means you're going to have volume and temperature left, because otherwise you just have the gas constant. But we would just use ideal gas law if that was the case. Excuse me. Alright, so we have volume and temperature. So let's plug in volume and temperature. Say if 23 liters of gas at 300 Kelvin. Actually, let's do this in 23 degrees Celsius at constant pressure. Wow, that is one ugly R. Alright, if 23 liters of gas at 23 Celsius at constant pressure, so there's your keyword right here. At constant pressure increases in volume to, I don't know, 80 liters. What is its temperature? Here, let me move this over. I don't know why I'm writing like that. It's kind of annoying. Alright, so what is its temperature? So this is solved by V1 over T1 equals V2 over T2. So in this instance, we're going to have our V1 and T1. And then temp must be in kelvins. So, and then I didn't specify, but let's just say we're going to do what is its temperature in Celsius. So I'm going to copy this, and we're going to go to the next page. If you need to copy that, go back and pause the video. Alright, so first things first, we have to convert this. So you add a 3 there, that's going to be 296 kelvins. So we have 296 kelvins divided by, oh, whoops, wow, what am I doing? We have 23 liters over 296 kelvins equals 80 liters over T2. So we have to figure out what T2 is. So you can either cross multiply, do it algebraically. I'm going to show you the algebra way. So T2 times this equals 80 liters. So let's rewrite that. T2 times 23 liters over 296 kelvins equals 80 liters. You divide out 23 over 296 as one term. So that's going to cancel. And you divide 23 liters over 296 Kelvin. So if you just plug this in the calculator, it's going to give you the same thing, but this is actually saying you have 80 liters times 296 kelvins over 23 liters. And then that is equal to T2. So let's plug that in the calculator. And then I'm going to do it the way that it was written the first time. And then that means that temperature 2 is going to be 1,000 kelvins, 1030 kelvins. And then if you do it this way, you're going to get the same answer. 80 times 296 divided by 23, same thing. So, anyways, this would be your answer for T2. And then we have to convert this to kelvins, to Celsius. So 1030 kelvins minus 273. And then I'm not doing that by hand because I'm not in the mood. So that's going to be 757 degrees Celsius, which would be your final answer. Let me erase that so I don't confuse anybody. Okay. If you need to copy this, go ahead and pause the video and do so. I'm going to go on to Avogadro's law. We did not do Graham's law, but anyways, Avogadro's law. So, Avogadro's law is just the relationship of the number of particles or its moles and its volume. So, your key word is moles and volume, and that's it. So if you don't see temperature, you don't see the pressure, you just see this, there you go. That is your key thing that you're looking for. So I like using balloons for this, I guess because it's easy to visualize for you guys and for me to explain. So a balloon consists of, let's do 0.372 moles of gas and has a volume of, we'll say 8.2 liters. If 0.452 moles of gas are added, what is the volume of gas? So this one, super simple. The equation is V1 over N1 equals V2 over N2. So we're trying to find out what V2 is. So we already know that V1 is 8.2 liters divided by 0.372 mole. And then that's equal to V2 over N2, which is we have to solve something. N2 equals 0.372 mole plus 0.452 mole. I ran out of room. Let me move this over here. Okay, so that's 842 or 824. So we have 0.824 mole. Double check. Let me double check that because sometimes I do math in my head wrong. 372 plus 0.452. Yeah, that's good. All right. So this would be equal to N2. So you plug that in over here. So I'm going to copy this. We're going to go to the next page. Okay, so that means we have 8.2 liters over 0.372 mole equals V2 over 0.842 mole. And what we're going to do is we have to isolate V2, so you just multiply both sides by 0.842 moles. And conveniently, this cancels the moles out, and we're left with liters. So let's plug it in the calculator. And that's 0.372. So that means that volume 2 equals like 18.56. So 18.6 liters. And that's how you would solve a problem with Avogadro's law. See what I'm doing on time. Alright, cool, I got plenty. Alright, and now we have PV equals nRT, or the ideal gas law. So sorry, excuse me. Ideal gas law. This is when you have 3 variables. You're going to know you're going to be using it because none of the other ones have 3 variables. Now, things you need to be aware of. Pressure has to be in atmospheres. Volume is in liters. N is the same, it's moles. T is kelvins, has to be. And then R, 0.0821 liters times atmospheres over moles times Kelvin. Okay. So these are values you just need to know. But for instance, let's say I was like, what is the pressure? I'm going to start out with an easy one. And then we'll do a harder one. And that'll be it. Because I went over density of gas, but I'm not questioning you guys on that. Like that's pretty easy to figure out. I'm going to give you the formula, but it's not that hard. So, what is the pressure of, we'll do a gas with, or we'll do 2.3 moles of gas in that occupies a volume of 70 liters at a temperature of 700 Kelvin. We'll do that. You didn't know that's super hot. So, yeah, let's do that. PV equals nRT. So you're looking for the pressure. All you got to do is divide the volume out, and then you have your equation. So P equals nRT over V. So let's plug the numbers in. Pressure equals 2.3 mole, 0.0821 liters times atmospheres over moles times Kelvin times 700 Kelvin, and then divided by 70 liters. So let's plug this in. 2.3 times 0.0821 times 700 divided by 70. So the pressure of this gas would be at about 1.88 atmospheres. And the reason it's in atmospheres is the moles cancel, the liters cancel, and the kelvins cancel. So that was a pretty straightforward one. But on, your examination, much like your quiz, I'm not going to be asking all simple ones. There's a few on there, just for time. But, for instance, let's say, we'll do propane. Or no, we'll do ethyl alcohol, which is C2H5OH. Alright, so we have to figure out the molar masses before anything. You have 12.3 grams of C2H5OH at a temperature of 392 kelvins plus this pen. At a temperature of 392 kelvins and a pressure of 795 torr. What volume does the gas occupy? So, doing this problem, you have to analyze some stuff. You're not given moles directly. You're given temperature in kelvins. Usually I'll give you about 2 out of 3 that you'll have to convert. 3 of them, it's a little bit, but anyways. Then you have 795 torr. So let's convert this to moles first. So C2H5OH, that's 16, 1, 5 plus 1 is 6, and then you have 24. So this right here is 46 grams per mole. If you do not remember how to do this, you need to go back and review the molar mass video and go over how to find that again. So you have 46 grams per mole. 12.3 grams of C2H5OH times 1 mole over 46 grams C2H5OH. And then this will be equal to 12.3 divided by 46. And then this is about, we'll just do 0.267 moles. Alright, so we have that much gas. Our temperature, we already have in kelvins, pressure. So we have 792 torr times 1 atmosphere over 760 torr, because that would be your conversion factor. So let's plug this in the calculator. And then this is equal to 1.04 atmospheres. And that 0.04 is actually going to be a big deal in the accuracy or precision of your ideal gas law. Okay, so we have all our values, and let's plug it in. And I'm going to write T down here just so we don't have to look up. It's 392 Kelvin. All right, so we're looking for the volume. So V equals nRT over pressure. So that would be V equals 0.267 mole times 0.0821 liters times atmospheres divided by moles times Kelvin, and then 392 kelvins. And that's divided by the pressure, which is 1.04 atmospheres. So let's plug that in the calculator. 0.267 times 0.0821 times 392. Then that's divided by 1.04. So our volume is, this gas would take up about 8.26 liters. And then that would be how you would solve that. Now, yeah, that's pretty much it for your test. This was supposed to be just like a quick recap of everything that's going to be on it. How to do the problems. And yeah, if you need extra help before your test, you can come to my office hours and we can go over problems. And if you need help with any of the other stuff, please come to my office hours or email me, and I'll try to get back to you as soon as possible. If you email me, but if you come to the office hours, I help immediately. Alright, and that's it for this video.